Hello, you're welcome back. Okay, so we are still looking at the solution to nonlinear ODE. Okay, so we see that an ODE of the form is of the form y prime plus p of x multiplied by y equal to r of x multiplied by y raised power n is nonlinear. And of course, we know that what makes it nonlinear is this y raised power n that is actually introduced to this particular equation. Okay, so now we already know that we can solve such equation by reducing the equation, the nonlinear equation, to linear equation. And how do we achieve that? We achieve that by introducing a variable, a changing variable. Okay, where we now use u to represent the independent variable y raised power minus n of the independent variable y raised power 1 minus n. Okay, the n here represent the power of the of the uh, of the of the dependent, not independent, please pardon me, of the dependent variable. Of course, y is the dependent variable. Okay, so now for me to actually illustrate this, for it to make sense, I'm gonna use a simple example, right? So I have some questions here which I'm gonna solve, right? So I'm starting with the a part of the question. Okay, so I hope you're ready. Let's go. So a part, I'm looking at the solution to y prime equal to ay minus b square. Okay, so let's do that. Okay, number one question. Okay, I'm looking at the solution to y prime is equal to, okay, ay minus by square. And of course, I need to write this equation in standard forms by taking ay to the other side of the equation. Okay, so this is going to be equal to y prime. Ay goes over, that's going to be minus ay. Okay, so it equal to minus by square. Okay, so I can now introduce the variable. Remember the n now. Y raised power n in this case is y raised power 2, which simply means that the n now, okay, is 2. So introducing changing variable, where we now use u to represent y raised power 1 minus n, and the n now is 2, right? Okay, so if we should do this, 1 minus 2, that gives me minus 1. So what is the whole idea of please pardon me, okay, that's going to be y raised power minus 1. Okay, so what's the whole idea? The whole idea is for me to actually replace the dependent variable of y, okay, and of course the derivative of y by the new variable I've introduced u. Okay, so which simply means that from here now we know that I know y here is equal to u is equal to y raised power minus 1. So I need to actually find the derivative of u with respect to x. How do I find the derivative of u with respect to s? Because y here is actually a function of s. Please take note. Okay, you know very well that in this y is the dependent variable. Why? Because it depends on x. Y is a function of x. Okay, if I've actually treated a function. So now I have introduced another variable. Okay, u. So now I say that u is actually a function of y. U is a function of y according to this expression, and already y is also a function of x. Now, in calculus, when we introduce calculus, okay, in differentiation, such a function is what is known as function of a function. Okay, when I use u to represent y, which y, okay, when u is a function of y and this y also is a function of x, we call such function of a function. So which simply means that if I want to differentiate u now with respect to x, okay, I'm going to apply chain rule. If you can still remember chain rule. So if I'm to differentiate u with respect to x, first I have to differentiate u with respect to y first. Okay, then multiply by, I have to now differentiate y with okay, I have to differentiate y with respect to x. So this is called chain rule. All right, so now, of course, you know that the u with respect to the x is something as u prime. Okay, so then I have to differentiate u with respect to y. So I'm differentiating this u with respect to y. If I differentiate y raised power minus 1, of course, you know how to differentiate power, okay? Minus 1 comes over as coefficient. Then that's going to be y raised power minus 1 minus 1. All right, then multiply by dy dx, okay? So this is going to be u prime is going to be equal to, of course, this is going to be minus y raised to the power of minus 2, okay? The y dx, of course, you know that I can represent that as y prime. Okay, so let's proceed. Let me divide this board, okay? Now come to this side. So proceeding now, I've gotten my u prime. Remember, the whole idea is for me to replace practically everything that has to do with y, okay? With in this equation with u, okay? So now I have to make y the subject, y prime the subject of formula. So invariably now y prime now is going to be equal to u prime, okay? All divided by minus y raised power minus 2. And of course, if you simplify this, is something as minus u. Remember, y raised power minus 2 is a reciprocal, okay? If I invert it, it will be y square, okay? I believe that you know indices. So now substituting, so what simply means that in that expression, any place I see y prime, I'm going to use minus u, okay? Minus u prime, please pardon me, okay? Multiplied by y square. And of course, any place I see y, remember from my introduction, from my variable, okay? U is equal to y raised power minus 1. U is equal to y raised power minus 1. So invariably now, that simply means that u is a reciprocal, okay? U is simply the reciprocal of y. So if I want to get y also can be expressed as the reciprocal of u. So I'm going to actually replace my variable both for y prime and y into the original equation. Now let's now go there. So this is my original equation, okay? So if I have y prime, okay, this y prime, I'm going to replace it by what I have here. Remember, y prime is minus u y square, okay? So I'm going to have minus u, okay, u prime y square. Then minus a, remember a multiplied by y is the reciprocal of u, okay? That's a all over u equal to minus b y square. Of course, you know that y is the reciprocal of u. So since it's squared, that's going to be minus b u square. Okay, I hope that is well understood. Okay, so now this is the equation. Now this equation now have actually replaced the y with y prime with u prime, okay? Then of course y with u. So but this equation is not in a standard form. Why do I say so? Okay, because if you look at it critically, in a standard form of every ODE is such that the derivative of the function doesn't have any coefficient, all right? So which simply means that I need to actually put this in a standard form by removing this y square, okay? So I have to divide through. I have to divide through by y square, okay? So I can get rid of this y square. All right, so now let's do that. So dividing through by y squared, I'm going to have u prime y square divided by y square. Okay, then minus a, okay, all over u still divided by y square. Okay, so equal to minus b all over u square, right? Divided by y square. Okay, so of course, remember this, I've not totally eliminated y. I still have y square. How do I actually eliminate? First of all, y cancels y, so I'm left with minus u prime, right? Okay, minus, remember I told you that y is a reciprocal of u, so y square will not be the reciprocal of, okay, u square. And the reciprocal means that I have to invert it. So in this case now it's something as writing a all over u. Of course, if I do reciprocal of this in the denominator, the u square comes up, okay? That's going to be u square up here equal to minus b. The same thing happens y is the reciprocal of u, okay? Then y squared is still going to be the reciprocal of u squared. So that's going to be times, okay? Of course, the u squared comes up so that the equation can still be broken down as minus u prime minus u squared divided by u. That's going to give me u. So I'm going to have au, okay, equal to u squared divided by u squared, that is 1. So equal to minus b. All right, so now to finalize it, remember all I'm doing is to make sure that I reduce this equation to what? Linear. And you know what it means by reducing it to linear. Okay, so that simply means that at the right hand side, there won't be any y raised to power, okay, attached to this particular function. But first of all, let me simplify this. I have to, since I have minus minus at both sides of the equation, let me factorize, okay? Let me factorize the sign. I take minus out, right? Then inside the bracket, I have minus, I have u prime. And of course, since minus is already outside, for this, okay, becomes plus. And of course, you know that if you open this bracket, you still arrive at this, okay? Equal to minus b. All right, so that way minus can actually cancel minus. So my equation now becomes u prime, please don't, that's u here, right, plus au equal to b. Okay, so that is whole idea. So by introducing this variable, now you can see now the variable u, the equation that was originally non-linear, okay, is now a linear equation. The equation that was originally non-linear is now a linear equation. Why? Because I have u prime, okay, au, then of course equal to b, right? So this is a linear, this is now linear, okay? So I'm going to solve this equation based, okay, on u being my dependent variable. So in this case now, I can now solve it. Remember how we solve a linear non-homogeneous equation by applying integrating factor. So by applying the process of integrating factor to solve this, if you can still remember, okay, I can simply conclude that my r of x, okay, is equal to, of course, the function at the right hand side, which is equal to b. Then of course my p of x, okay, is gonna be equal to that coefficient, the coefficient of u, right? Because u now is the dependent variable, right? And so that's gonna be a, p of s is a. So don't forget that I still need my integrating factor for me to be able to do this. Okay, so integrating factor becomes the exponent of the integral value of p of x. So that's the integral value of a respect to. So now a in this case is a constant, right? So if I integrate a, right, with respect to x, you know that when you integrate a constant, what you have is that constant multiplied by s, right? Okay, so that is my integrating factor. So I can now go to the general solution. So the general solution becomes of this linear equation, okay, this converted linear equation now becomes, you know how we do that, u, okay, is equal to the integral value of, okay, my integrating factor, which of course is exponent a of x, exponent ax, okay, then multiply by the r of x, right? Don't forget the r of x b, okay, with respect to the x, okay. Don't forget to also bring in your constant, then divided by the integrating factor, which is exponent of a of x. Okay, so now let's do this. So let's solve. If I'm to already know b is actually a constant, so I can take it at the behind the integral, okay, the integral value. So I need to, what I'm integrating here now is exponent of ax. Remember, if you are integrating exponent of x, as here is a function, okay? So it's a function of a function. If you have actually gone through my integration of function of a function of a linear function, okay? So the first thing you need to do is just integrate a to differentiate ax, okay? That's gonna be, to integrate exponent a of x is gonna be a multiplied by, when you integrate exponent ax, you still have exponent ax. Okay, so in case you've actually forgotten this, I'm sure you should go back to that particular tutorial, okay, of integration. All right, so then plus c all divided by exponent ax. Okay, so to finalize my answer, I'm gonna have u is gonna be equal to, I'm separating this, okay, this fraction. Of course, if I separate this fraction, exponent ax divided by exponent ax, that gives me 1, okay? Then plus c, okay, divided by exponent ax, which is something as c divided by exponent ax is something as exponent, okay, minus ax. All right, so with what I have here, okay, this equation is not complete. Why? Because the variable, I have not returned back the variable I changed. Remember, the u wasn't originally in in my equation. I was one that introduced u. Okay, remember, u is the reciprocal of y. Okay, so that means 1 over y is equal to ba plus c exponent minus ax. Okay, so invariably, now to get y, I have to find this for the exponent of the right hand side. So it's gonna 1 over ba plus c, okay, of course, the reciprocal of this, that will be divided by, okay, yeah. Okay, so I hope you understand. That is my answer. Okay, I still have another question that I will need to solve. Okay, this one goes like this: 2xy prime is equal to y square minus s square. So let's do justice to that. Okay, I'll clean up now so that we work. Okay, so 2xy y prime is equal to y square minus s square. And of course, before I begin solving this particular equation, okay, before I solve it, or to before I investigate whether it's linear or non-linear, I have to actually write it in standard form. So which simply means that I have to eliminate this to xy, okay? So I have to divide through by 2xy so that y prime will be alone. Okay, so that's gonna be divide by 2xy, and of course also divide this by 2xy. So I'm dividing through by 2xy. If I divide by 2xy, 2xy cancels 2f, I have y prime equal to y squared divided by y. I have just y, so I'm going to have y, okay, divided by x minus s squared divided by s. I just have x at the numerator, okay, x then divided by 2y. Okay, so now how do we actually work on this now to know whether it's linear or non-linear? Okay, the very first thing you should know that this is y, okay. Remember, the function that's attached to y is p of s, so that should come to the other side of the equation. So I'm having y prime, okay, so then minus y all over 2x. So now where we'll be having the nonlinear function is at the right hand side, which of course is, this is something as saying x all over 2. Then if you should do the reciprocal of this y is y raised power minus 1. So we simply mean that the nonlinear term, okay, or the term that actually makes this particular relationship to be nonlinear is y raised power minus 1, okay. So now I have to reduce it to linear form by introducing u, okay. So remember, now u is going to be equal to y raised to power 1 minus the power of the y, right? And the power of the y is minus 1. So if I should do this, u now becomes y raised to the power of minus is plus, okay? So that's going to be 1 plus 1, that gives me 2. So you know what I'm going to do after changing this variable is to replace it here, but first I have to differentiate, okay? All right, so let me differentiate. Now differentiating, okay, you know very well that if I do du dx, this is a chain rule. Okay, to get the u dx, first of all I have to do du with respect to the y. I have to differentiate u with respect to y, then times y, the y with respect to the x. Okay, so now let's see how that works. So this is gonna be, of course, the u with respect to the x is something as u prime. Okay, so the u with respect to the y, if I should differentiate this with differentiate u with respect to y, of course you know what I'm gonna get, that's 2y, right? Then of course the y with respect to the u, that's gonna give me u prime. So that's number one. Number two is that I still need to get my y, right? Because I'm replacing both y, please, the y the s is y prime, please, but not u prime, okay? So 2y prime. So I want to make y prime the subject, okay? So y prime is gonna be what? U prime divided by 2y, because I have to put that, replace that in that in the equation. Why is my equation? Okay, here is my equation. Okay, so let's proceed. Then in the case of don't forget, in the case of I still need to substitute for y also. Okay, since already from here we are u is equal to y squared, so invariably now for me to get y from this relationship, y definitely would, y would be the square root of u. Y will be the square root of u. Okay, so now if y is the square root of u, okay, so I can now go ahead with my substitution. Now let's substitute. Okay, this is my equation. Okay, so y prime, any place I see y prime, okay, I am going to substitute u, that's u prime divided by 2y. Okay, going forward, then the next is minus y, which of course my y is the square root of u divided by 2x. Okay, equal to minus x, okay, all over 2, then then the reciprocal multiplied by the reciprocal of, okay, y, reciprocal of y, okay, and of course the reciprocal of y is gonna be, is that a mistake? Okay, yeah, the reciprocal of y, that's gonna be 1 all over the square root of u. Okay, so let's proceed. Okay, so now in this case, having done this, you know what I'm going to do next? I need to transform this equation to a standard form, because I have to, in this case now I'm going to multiply everything by, because I want to eliminate this to y as the denominator, okay? So if I want to eliminate the denominator, I have to multiply through by 2y, okay? So I have to multiply everything. So I'm going to multiply 2y by u prime divided by 2y. Okay, then minus 2y, okay, then multiply by u prime, okay, divided by 2x, equal to 2y, right? So that's minus 2y, okay? 2yx all over 2 times 1 all over the square root of u. Okay, so let's proceed. Here we go. So now, of course, start cancelling 2y cancels 2y, so I'm left with u prime minus, okay, 2 cancels 2 here. Then don't forget what my y is, okay? My y is the square root of u. So I have square root of u multiplied by square root of u, that gives me u. So in this case now, having u here, all over x, okay, is equal to, of course, 2 cancels 2, okay? And don't forget what y is. My y is the square root of u, okay? So square root of u cancels square root of u. So I'm only left with just minus 1, if I'm not mistaken, okay? Of course, you know what I did here. Minus 2 have already, 2 cancels 2. Y is already, okay, not minus 1. This x. Y is already the square root of u. Square root of u divided square root of u. Okay, that's 1. So I'm left with just 1x, okay? So please, pardon. So that's going to be minus x. So as you can see now, with what I have here now, this equation now is said to be what, linear, okay? So I can solve it using the method of integrating factor, right? So now let's solve this by the method of integrating factor. Using the integrating factor, you should already know that my arrow of x, the function of x at the right hand side of the equation, is minus x, okay? And of course my p of x, okay, the function that's attached to u, that's equal to minus 1 all over x. All right, and then my integrating factor, I of x, is equal to the exponent of the integral value, okay, minus 1 all over x with respect to x. Let's do this. Of course, if you should evaluate, excuse me, so this is going to be the exponent of, if you evaluate 1 over x, the integral value of 1 over x, that's ln x, okay? That's going to be minus ln x, okay? And you should know very well, by a virtue of a law of logarithm, this is something as exponent ln of 1 all over the reciprocal of x, okay? I've shown you, I've done this before, because of the minus 1, okay, at the as the coefficient of the ln, right? Okay, so let's proceed. Here we go. So you know very well that exponent cancels ln, so invariably now my integrating factor now, I of x, is going to be equal to 1 all over x. Okay, proceeding, let's conclude this so I can now get my solution, okay? So my general solution, don't forget, is always equal to the integral value of the integrating factor, which is 1 all over x, okay, multiplied by the r of x, and my r of x is minus x, okay, of course with respect to x, plus c, okay. Please pardon me, don't forget that I have not introduced my y, okay? So the independent variable in this case now is u, so I'm still gonna be, I've not brought, okay, I've not brought in the y, right? Okay, so now let's proceed. All divided by the integrating factor, which of course is the reciprocal of x. Okay, let's go there. So having done this, x divide x, I'm gonna have minus 1. Okay, so So what I'm having here now, this is minus 1, okay? So what I'm actually integrating is the integral value of minus 1. And of course, if I should integrate minus 1, that's simply going to be minus x, okay? Then plus c. Now don't forget this reciprocal. This reciprocal will definitely have to comes up, okay? To be to multiply, right? So this is going to be u is equal to open this bracket, right? That's going to be s multiplied by minus s. That's going to be minus s squared, and of course cx. Okay, I'm close to the end. I'm very close. So don't forget that I have to introduce my u. Okay, remember my u was y square. I was the one that actually my u was, what was my u? Yeah, my u was y square. Okay, my u was y square. We should go there. All right, so my u, remember when they introduced the u to be equal to, okay, y raised power of 1 minus into minus 1, okay, which gave me y square. So my u is y square, right? So u is y square, okay, minus s square, then plus cx. So I can possibly take the minus s square to the rest of the equation. So this is going to be equal to y square minus s square comes s square, okay, equal to cx. So this is the solution to that particular equation. So it's as simple as that. All right, I'm going to give you the opportunity to go through what you've tutored. Just take your time, okay? Go through it. Don't just read it. Don't just watch the videos. Solve the same example, okay? And I'm sure that you definitely get used to it. All right, see you in the next video. Thank you very much.